Hi, my name is Saurabh Pant and welcome to the Rank Booster series video number 5. In the last video, I talked about the comparison of bond angle and bond lengths in the chemical bonding. At that time also I told you that next video I'll be talking about the trick to find the hybridization. So without wasting any time, let's start it immediately. So understand this trick I feel is the fastest trick for the hybridization or calculation of the hybridization. So directly dekho yaar, what to do? First thing you should know the basic idea that steric number which I'll be representing as Sn, steric number. For example, if it is 2, 3, 4, 5, 6 or 7, which hybridization would come? So 2 means there are 2 orbitals involved, so sp hybridization will come. 3 means sp2. I think it's easy. 2 plus 1, 3. 4, sp3. 3 plus 1, 4. 5, sp3d. Obviously not sp4. Don't be stupid enough to write sp4. Why? Because any shell has only 3 p orbitals in a subshell of p, that is px, py and pz. So obviously if you want 5 orbitals, so sp3d. I'll be talking about this also in detail in the next part of the video. sp3d. Very nice, beautiful concept it is. 6, sp3d2 and 7, sp3d3. I think that is pretty simple to understand here. So here sp, sp2, sp3, sp3d, sp3d2 and sp3d3 are different hybridization corresponding to the steric number. So now what is the trick? The trick is very simple here. The trick is, number 1, find total valence electron including charge. Find the total valence electron including charge. Let us say the total valence electron comes out to be equal to V. Let us say V is the total valence electron. So A part, if V is more than 8, then divide by 8. Number 1. And number 2, divide remainder, if anything is the remainder, by 2. ठीक है भाई साहब. Second, if the valence electron are less than or equal to 8, understand equal to 8 also will come in the second category. So if it is equal to 8, don't divide by 8. So if it is less than equal to 8, then what? The number 1 you will just divide by 2. Khatam. That's it. ठीक है भाई साहब. Finally, note, if remainder left, obviously sometimes odd number can also be there. Odd number cannot be divided by the 2 completely. You will be seeing the examples, you will understand basic mathematics. If remainder is left, this implies it is an odd electron species. Okay, bhai sahab? Obviously this technique you will not use for finding the odd electron species. Why not? Because for odd electron you can simply add the valence electrons. For finding if it is an odd electron species or not, just simply add the valence electrons total. And if the valence electron is odd number, odd electron species. If valence electron is even number, even electron species. But anyway, so if one remainder is there, one remainder is left, then bhaiya it is odd electron species. So this is the trick for finding the hybridization for any specific compound. Now, before going ahead, how to find the valence electron? Very simple. Group number you can check. For first and second group, that is lithium till the last, ठीक है भाई साहब, and here beryllium till the last, the valence electrons are 1 and 2. I can write the valence electrons here, 1 and 2, that is a group number. After that D block comes in the middle, ignoring that, coming to the P block directly, so 13, 14, 15 and so on group. So bhaiya for the P block, the trick is pretty simple. Valence electron is equals to group number minus 10, clear cut. For example, for 13th group, like boron family, for 13th group, there are 3 valence electron, or simply unit place you can take. For carbon family, 14th group, there are 4 valence electron. For nitrogen family, 15th group, 5 valence electron. So here let us use this trick now to find the hybridization of a few molecules and understand one more important thing. This first part, one more interesting thing you will also get from here. That means this first part will give you double the answers for it. Chaliye, so let's carry on. This thing you have to remember here. Okay, na? So let's start. Even if you don't remember, you can find using sp, sp2, sp3 by counting the total number of orbitals involved, the steric number. So let's start with one example, PCl5. Very common. Now phosphorus valence electron. Phosphorus is from nitrogen family, so valence electrons are 5 chlorine 7, halogen family 7 valence electrons, so 7 into 5, so 7 5 35, 35 and 5 40. Understand how to solve. Solving is very important. So PCl5 valence electron, phosphorus 5, chlorine 7, there are 5 chlorines, so total 7 into 5 35, 35 plus 5 40. So you have 40 valence electron. 40 is more than 8 obviously, so I will be using this technique. So 40 will be divided by 8. बढ़िया यार. So 8 5s are 40. तो भैया 5 is the steric number. So sp3d. 3 plus 1 4 plus 1 5. sp3d hybridization as PCl5 is going to be. Take one more example. PCl6 minus. PCl6 minus phosphorus is valence electron 5. Chlorine 7 into 6 42. Here you can understand one negative charge is there. In the case of negative charge, you have to add one electron. That's very obvious here. If you have a negative charge, that means you got one extra electron. So add that. So total valence electron including charge means this. So 42 plus 1, 43 plus 5, 48. So 48 divided by 8. So 8 6 are 48. तो भैया बहुत बढ़िया sp3d2 came. Steric number 6. So sp3d2. One more example I can take. PCl4 plus. So if I take PCl4 plus, so phosphorus 5, valence electron I am finding now. Phosphorus 5, chlorine 7, 7 into 4 28. Now because you have a positive charge, that means you lost one electron, to subtract 1 from here. Pretty simple. 7 4 28, 28 minus 1 27 plus 5 32, and bhaiya clear cut 8 4s are 32, so sp3 hybridization will come. Now obviously a doubt will come ki sir, always it will be divided completely, sometimes it can be a possibility that remainder can also come. Obviously yaar, let's take one example. Let's take the example of NCl3. Very beautiful example. NCl3 is there. People usually know this idea very well, hai na? One example I can take NCl3. So nitrogen valence electron will be 5, chlorine 7 into 3, 7 chlorine, and 7 valence electron chlorine has 3 number of chlorine. So 21 plus 5, 26. So very beautiful. 26 divided by 8 3s are 24. Badhiya hai. 8 3s are 24. Understand now. Remainder 2. 8 3s are 24. Remainder 2. Now what to do? This remainder is divided by 2. So I will divide this further by 2. 1s are 2. And understand this 3 plus 1 should be added for the steric number. So your steric number is 3 plus 1, that is 4. So sp3. One more beautiful thing I will show you. 3 are the number of sigma bonds and 1 is the lone pair on central atom. So this technique can be used for finding the lone pairs on central atom also for valence electron more than 8. Total of the molecule. Like NCl3, you got 3 plus 1. So bhaiya 4. See 4 5 more examples till the time you are able to digest this properly here. Okay, bhai? So let's take one more example. Let's take the example of XeF2. Okay, how many valence electrons, lone pairs are there on central atom? Xenon is a noble gas. Noble gas have octet. So bhaiya valence electron 8. Fluorine, halogen. So 7 into 2, 14. If you practice 30-40 questions here, even if you see this whole video also, you'll be able to remember the valence electrons as well. So don't be afraid of that. So 14 plus 8, 22 electrons. Badhiya, 22 more than 8? Yes sir. Then what to do? Divide by 8. So 8 2s are 16. Because 8 3s are 24. So it will go 2 times 16. Remainder 6. Now what to do? Divide this 6 by 2. So 2 3s are 6. बहुत बढ़िया यार. Over. So this is 2 plus 3. So 3 plus 2 total steric number is 5. So sp3d. But if I ask you how many sigma bonds? 2. How many lone pair on central atom? 3. So XeF2 has 3 lone pair on central atom. In fact, you can write like this also to show that this is the structure of XeF2. One more example I can take. XeF4. Bhaiya, example to as many you do as possible is very good. So 8 valence electron. Xenon 8. Fluorine 7 into 4, 28. 7, or I can write like this also. No? 7 into 4, 28. So 28 plus 8, 36. है ना भैया? 28 plus 8, 36 divided by 8. 8 4s are 32. Remainder 4. Now what to do? Remainder to be divided by 2. So 2 2s are 4, remainder cancel. तो भैया 4 plus 2 6. So sp3d2. sp3d2 6, that is there in the beginning of the chart. So understand, 4 sigma bonds are there, 2 lone pairs are there. तो भैया very quickly you can write 4 fluorine as sigma bond and 2 lone pair like this. So lone pair on central atom, how many lone pair on central atom? 2 lone pair on central atom. Now I can remove this trick from here and I can give you some examples of the trick where less than equal to 8 electrons will come. So for example, I have ammonia. I think everyone knows ammonia is sp3, but still, let's see this example how to get the answer using this trick. So nitrogen 5, hydrogen 1 1 1. So each one has 1 1 electron into 3, total 8. When the valence electron is 8, then also divide by 2. But in this case, you will not be able to get, if the number is less than equal to 8, you will not be able to get the sigma bond and lone pair separately. Then sir, for such question, how to get lone pair on central atom? Very simple. This is steric number. We know sp3 hybridization has come, that is the end of the story. How to get lone pair on central atom? Very simple. Steric number minus terminal atom. What is terminal atom? This is called central atom. And this is called terminal atom. So steric number is 4. Terminal atoms are 3. So 4 minus 3, 1 lone pair will come. Sir, this logic I can apply here also 100%. Like total steric number was 5. है ना भाई? So lone pair on central atom, I would prefer obviously to use this technique when the number is more than 8, but you can apply this here also. कि lone pair on central atom will be steric number 5 minus how many terminal atoms can you see? 2. So 3 lone pairs will come on the central atom. Let's see some more examples here to become very perfect in this part. So if I take one example of NH4 plus, let us say NH4 plus. ठीक है भाई? NH4 plus, one example I can take NH2 minus. Let's try to solve both of them. So nitrogen valence electron 5, hydrogen 1 1 1 1, minus 1. Why minus 1? Because sir, plus 1 is there, so 1 electron lost. 4 minus 1, 3, 5 plus 3, 8. 8 divided by 2, 2 4s are 8. So sir, sp3 hybridization. Any lone pair on central atom? No sir, lone pair on central atom will be 0. Why? Because steric number minus terminal atoms. How many steric number? 5. How many atoms can you see apart from nitrogen? So sir, 4. So sir, 0 answer came. NH2 minus, बहुत बढ़िया. For NH2 minus, nitrogen valence electron 5. Hydrogen 1 1 2. Obviously 1 1, there are 2 hydrogens. And minus 1 or plus 1. So this time plus 1. Why plus 1? Because negative sign means electron came. Positive sign means electron went. So went, subtract, came, add. As simple as that. Again 8 comes. So this time you will get 2 4s are 8. Sir, same hybridization sp3? Yes. Sir, no difference at all? Difference is there. Find the lone pair on central atom. So भैया देखो lone pair on central atom will be, क्यों भैया? Will be steric number minus terminal atom ना यार. So what is the steric number you found? Sir, 4. Terminal atoms are 2 hydrogen I can see apart from nitrogen. So there are 2 lone pair on the central atom. Beautiful idea clear, cute idea clear. Any problem up to here? Take one more example here. Let's take XeO3. So xenon, that is in your course also. XeO3, xenon 8, oxygen 6 into 3, 18. Valence electron of oxygen are 6. 6 into 3, 18. So valence electrons are 8 plus 18. How much? 26. ठीक है भाई साहब? Now 26 divided by, sir, more than 8. So divide by 8. 8 3 is 24. Remainder 2. Sir, 2 ones are 2. So sir, 3 plus 1 steric number is total 4. sp3 hybridization, 3 sigma bond, 1 lone pair. Whenever you get something like this, the second number which you are getting by dividing by 2, the remainder, that is more than 8 logic. Whenever the total valence electron is more than 8, then this logic works very well. Ki 1 lone pair and 3 sigma bonds are there. So tetrahedral you can draw. 1 lone pair, that is battatala here. Battatala means bald head. Ganja. So this is ganja here. And this is double bond O, double bond O, double bond O. Understand? Hybridization gives no idea about pi bonds. How many pi bonds will be there? You have to check the octet of oxygen and check here and get the answer. But that you will get by the Lewis dot structure easily. But understand, hybridization just gives you the idea about sigma bond and lone pair. ठीक है भाई साहब. Some more examples we can also. So now let us try XeF5 plus xenon valence electron 8, fluorine 7 into 5, 35. -1, why? Because one electron went away. Positive charge came means went away. So total 42 valence electron came. So 42 divided by 8. So 8 5s are 40. And bhaiya 2 1s are 2. So total steric number 6, that is sp3d2. But clear cut 5 sigma bond 1 lone pair will be there. And this is how you can find the hybridization by using this trick. But understand, this is only for single central atom. For multi-central atom, you have to know the structure. For multi-central atom, example sir, example is N2O5, N2O3, etc. P4O10. You have to mug up the structure from the NCERT. ठीक है ना भैया? Apart from that, understand this, that this trick of finding the hybridization can be used for any other example also, that is not a problem, but it is only for the single central atom. But in your course, very high valence electron questions are not there. So what is the meaning of very high valence electron? Don't worry, when you will do the question bank, you will not find such questions at all. Sometimes the valence electron becomes so high that 8 also cannot be used. In that case, we have to divide with 18, but those examples will not come in your course, so you can be very, very happy with this. So this is a shortcut trick you can use, and this will become very, very helpful along with the bond angle, bond length comparison, which I told you in the previous rank booster series. So that's all from my side. A quick hybridization technique I've told you, very helpful for NEET examination. Maybe you will get the correct answer in the NEET also. One question you can expect from this video directly in the examination. That's all from my side. This is Saurabh Pant signing off. Thank you.